So I'd like to sort of look at these problems again and sort of do them from a position which is perhaps less intuitive. And it's not less intuitive in terms of its technique, but it's sort of less intuitive in terms of the approach that you will have towards sort of the technique, if you will. When we're looking at a question like this, we can really reason through it and sort of understand why the conversion factors are what they are. But um, when it comes down to sort of execution, thinking about things can sort of be your enemy in some cases. So what we want to do for a question like this, it asks us to determine the number of moles of hydrogen atoms in 0.0885 moles of C4H10. So the idea here is going to be really first to understand what you want, and basically what you have and what you want, right? So what we're given is this particular number here, which is 0.0885 moles of C4H10, right? And now we're the plan. I mean, really, the goal is to take the what you're given, which is moles of C4H10, and we want to basically stretch our conversion factor all the way until we come out on the other side to having what the question is asking us for, which is moles of hydrogen atoms. And you really want to know what you need to work through in order to get to atoms from moles of a compound, right? And it's not something you memorize. The more you sort of study the relationships that basically underpin how all these things are connected, the more you'll be able to sort of navigate through basically these conversion factors. Um, if you think about it, you're starting from moles of C4H10, and you want to get to moles of hydrogen, right? Well, you want to get to moles of hydrogen atoms. So first, you would want to figure out how many atoms you have in the moles that you're given. So you have moles, right? And you want to figure out, well, how many atoms of hydrogen atom are there? But in order to get there, you can't just, there's really no conversion factor that can connect you from moles of a compound to, atoms, right? Of another compound or element in this case. What you want to do is you want to say, okay, well, first let me go to molecules, right? First let me go to molecules of the compound. And I say this because once you have the molecules, you'll be able to know by proportion how many atoms you have, because you know that you have 10 atoms of hydrogen per molecule. So you can go and so you can just multiply. If I had, let's say, 100 molecules of C4H10, and I know that and I want to find out how many atoms there are, then I know that in one molecule there's 10 hydrogen atoms. So if there's 100 molecules, then that'll just be 10 times 100, and that'll give me how many atoms of hydrogen there are. So it's sort of imperative to figure out how many molecules you have. So you're going from moles to molecules, and then once you get from molecules, you eventually want to get to hydrogen atoms, right? Atoms of hydrogen. And then once you have atoms of hydrogen, you want to go back to moles because the question is asking you moles of hydrogen atom. So that's really the approach here. And each of these, you're going to need a conversion factor, which will be able to cancel out with what you had. And I'll show you what that means. It'll sort of make a lot more sense once I get into the conversion factor process, which of course we have here. So 0.0885 moles of C4H10, right? And I want to get to molecules. So if I want to do that, if I want to get to molecules of C4H10, well, there's a conversion factor which will let me do that. And whatever this conversion factor is, you want to be able to set that conversion factor up in a way that you have moles of C4H10 in the bottom, and you're left with, in the numerator, you're left with what you want to convert into. And we want to convert into molecules of C4H10. That's what we want, molecules of C4H10. So do we have a conversion factor which can let us do this? And that's really the goal. And the answer is yes, right? There is a conversion factor which can let you do this, because you'll notice that 1 mole of C4H10 is Avogadro's number amount of molecules of C4H10, right? And this gets you to molecules of C4H10. So now once you have this answer, how many molecules of C4H10 are in these many moles of C4H10, if you were to stop right there, you would just have how many molecules are in 0.0885 moles of C4H10. And that doesn't really get you far. What you really want is how many atoms of hydrogen are, how many moles of hydrogen atoms are in 0.885 moles of C4H10, not just how many molecules there are in C4H10. So, you're at molecules and you want to now get to atoms of hydrogen. So you multiply again and you sort of continue the chain that we already have going. And, the next thing in the chain should cancel out molecules of C4H10, right? It should cancel out molecules of C4H10. So it's definitely going to be on the bottom. And once those cancel out, you want to be left with atoms of hydrogen. Atoms of hydrogen. And so you ask yourself again, and it's sort of, you're revisiting the same process of asking yourself the same thing, but you ask yourself again and you wonder, well, do I have a conversion factor which can essentially take me from which can equate in a way atoms to molecules of C4H10, atoms of hydrogen to C4H10? And the answer is yes, because you know that there are 10 hydrogen atoms per molecule, right? So there are 10 hydrogen atoms per 1 molecule of C4H10. And that gives you how many atoms of hydrogen there are. So, that works, right? But again, you don't want how many atoms of hydrogen there are in 0.885 moles of C4H10. You want to know how many moles of atoms there are of hydrogen, or how many moles of atoms there are in nitrogen. And so you'll multiply by something which will cancel out atoms of hydrogen and will leave you with moles of hydrogen. And so you would have something on the bottom which is atoms of hydrogen, right? And it will cancel out and leave you with moles of hydrogen. And that brings us to basically the first conversion that we learn about in chemistry, which is the fact that 1 mole of hydrogen is 6.02 times 10 to the power 23 atoms of hydrogen, right? And so once you do this, 0.885 multiplied by 6.02 times 10 to the power 23 times 10 over 6.02 times 10 to the power 23, you essentially will get an answer of 0.885 moles of hydrogen. So that's how you do it in a manner which sort of offers some security in terms of not being able to make a mistake, really, if your conversion factors are correct.